Hi, welcome to this tutorial where I'll show you how to create this hexagonal shockwave in 3ds Max using Tyflow. So to begin with, we'll go to the top plane. What I want you to do is create a plane from the Geometry tab. Make it 100 meters by 100 meters. You can give it 50 length segments and 50 width segments. This will create a finer topology for the shockwave to follow for the hexagons. That's what you want to do. Your polygon modeling, select edge, and then click anywhere on your plane and click, go back to polygon modeling, generate topology, and then click the hexagons. Now I just want to resize this plane. Click edit poly, you want to resize this plane until these hexagons look more uniform. That looks good. Okay. Next we're going to create a cylinder in the center of this. There we are. And what you're wanting to do is go bring our frames back to the start, turn your toggle auto frame on, and at frame 1 we'll modify the cylinder to be 0.1 meters in radius, and set a key or click K, and then we'll go to frame when the frame's near the end, and let's make it about 45 meters in radius. Add another keyframe, and we should see our cylinder growing in size. Great, now we're ready to start creating the shockwave in Tyflow. So create a Tyflow editor. We'll open the editor. Just before we do that, we go to the cylinder and make sure your cylinder has about 50 sides, and it has 5 cap segments and 5 height segments. Right, so we'll open back up the Tyflow editor. Create a birth object. Then in here, we'll want to pick the plane as our birth object. And we'll turn off the plane in 3ds, so we're just seeing the object in 3ds Max. And make sure your display is set to geometry. If it's set to something else, you won't be able to see it. Okay. Now, what we want to do is create a face fracture, and this will divide the plane into its different polygon surfaces. Make sure it has one face with the 0 variations, and then we'll do shell. Now this is going to create some depth to the polygon, and this is where we're going to create a bit more of a separation between all of these grids. So set the outer amount to 50. This will increase the height of it. The inner amount to 0. And what we want to do is create a bevel on the outer edge. It's about 5%. See, when we zoom in, we're seeing a separation between the hexagons. If I made it larger, it's a bigger change, but we'll leave it around, maybe go 8%. Okay, now to make the hexagons grow in size, do a surface test. And this is where we will select our cylinder as our test. I'll hide that cylinder now, so we're not seeing it. Okay, so now our cylinder will be a tester, and we'll need to create a new speed modifier that's separate. I want to connect this to our surface test, and here we should see it growing in size. And what we want to do is we want to change our direction to particle Z instead of random, so that it's all lifting up vertically. There we go. Now you can see it's all lifting up vertically. Make sure there's a interpolation variation of 0. Now I want to create a custom property after the shell, and this is where we're going to create a new TM value. So we'll go create new channel, custom TM channel, and we'll call this the original position. And this channel is going to return these lifted surfaces back to the original height of the plane. Okay, so once we've created that, we will make a time test for the speed. And make sure that this time test has a value of 5 and then we want to create a target location for this time event. So set target. I think it's find target actually. Go. Link these together. Go find target. Scroll down to the target location. Point closest to custom TM, and we'll select that original position. And now we should see this shockwave effect happening. What you can do, instead of having this rippling effect, you can add a slow modifier. Make it about 20%. Maybe lower the time test value a bit. But you can play with those settings to have less ripples. And if you want to bring this object into 3ds Max, you can create a mesh modifier.